Hi everyone, I am Husnina and today we are going to discuss about how to determine the percentage of calcium carbonate in eggshells through volumetric analysis. First, let's have a quick explanation. Do you know that eggshells contain calcium carbonate, which makes the eggshells have a hard surface? Well, calcium carbonate is a base and an inorganic salt that widely used in dietary supplement, antacid and as phosphate binder and manufacturing. Calcium carbonate, also known as calcite, chalk, and limestone. These examples are common to contain high percentage of calcium carbonate.
So, why do calcium carbonate contained in eggshell become our interest in this study case? First, this is because eggshell contain a high value of calcium carbonate, which is on average 2.2 gram. Other than that, it also often discarded without any further uses. So this is great to become our study material for the acid-base titration. Besides that, it also easily available and affordable compared to other chemicals.
Have you ever wondered what are the uses of calcium carbonate? Well, calcium carbonate commonly used in pharmaceutical for medicine and drugs. It is a food additive that is used for nutritional benefits, which is as calcium supplement. The supplement function as to treat any disease that related to lower calcium levels in our body. For example, antacid tablets, which is for gastrointestinal ailments, and as a phosphate binder for chronic disease. Calcium carbonate also used in tableting excipient used in the making of other pharmaceutical agents and foodstuffs. As I mentioned previously, calcium carbonate also used in the making of antacid tablets. Well, antacid tablets is a compound that neutralizes the hydrochloric acid in gastric secretions. Increasing pH level in the gut or in our stomach inhibits the action of pepsin. Therefore, increasing in bicarbonate ions and prostaglandins may also confer cytoprotective effects. Calcium carbonate may also be used to treat hypocalcemia, which is a condition of having low levels of calcium that leads to muscle cramps, numbness, and cardiac arrhythmias. Calcium carbonate is widely functioning to treat disease related to lower levels of calcium in our body. For example, hypocalcemia, where calcium level is less than 8.8 mg per deciliter. Osteoporosis, a condition where the quality or mass of bones decrease. Arthritis, where our joints suffer inflammation. Hypothyroidism, heartburn, acid indigestion, and GERD.
Next is the advantages and disadvantages of using volumetric analysis. First, it's simple to perform and does not require expensive and sophisticated equipment. Next, it provides an accurate and precise result when performed correctly. Furthermore, it able to determine the concentration, which include a wide variety of analytes such as acid, base, salt, and metal ion. Lastly, it does not require an expensive reagent or equipment to conduct the experiment. However, there is a few disadvantages, which is, firstly, is time consuming due to the complex analysis in which it requires a multiple titration. Next is the endpoint of a titration. It often determined visually, then it's not sensitive enough to detect a very low concentration of analyte. And lastly, it can be affected by the presence of interfering substances in the sample.
Now, let's head to the experiment. Firstly, take a look at the theory. So the theory for this experiment is that calcium carbonate naturally strengthens seashells, rocks, and eggshells. Despite its hardness, this chemical easily reacts with hydrochloric acid, producing two additional compounds, which are carbon dioxide and water. A decent eggshell typically contains 2.2 grams of calcium carbonate that makes up to 94% of a dry eggshell. The lowest amount of calcium carbonate discovered in eggshells is 78%. Even it is considered to be the lowest, it still covers more than half of eggshells. Therefore, to determine the percentage of calcium carbonate in eggshells, we are going to apply back titration method for this volumetric analysis. Why back titration is applied? Well, in this case, calcium carbonate is insoluble in water and eggshells may contain other impurities.
Next is the methodology. For this experiment, we use 1 egg, burette, 1 molar of HCl, 0.1 molar of NaOH, hot plate, retort stand, 3 conical flask, weighing scale, and lastly, mortar and pestle. The chemical equation for this experiment is CaCO3 plus 2HCl to CaCl2 plus CO2. There is 11 steps of procedure for this experiment. First, an egg is cracked in a container. All membranes are removed from the eggshells. The eggshell then heated and dried for approximately 10 minutes. The eggshell is crushed into the mortar and into small pieces. Then it has been dried with pestle. 1 gram of crushed shell was weighed and placed into 3 different conical flasks. 25 ml of HCl is pipetted into each conical flask and let it sit for a few minutes. Then the burette is filled with 0.1 molar of NaOH. 2 to 3 drops of phenolphthalein is added to the HCl solution. The HCl in the conical flask is titrated with NaOH from the burette while shaking the flask gently until the indicator changes color. Color changes and readings are recorded. Lastly, the step is repeated for the other conical flasks and all readings are recorded in the data table.
Now, let me explain about the calculation. Here we have two equations. First is CaCO3 plus 2HCl to CaCl2 plus H2O plus CO2. For second equation is HCl plus NaOH to NaCl plus H2O. Now, firstly, we need to find mole HCl initial. We use MAVA and we get 25 times 10 to the power of negative 3 mole. Next, we need to find mole of HCl unreact. From equation, we can find mole of NaOH. So we get 1.237 times 10 to the power of negative 3 mole. From equation 2, we can make ratio mole NaOH to mole HCl. So the ratio is 1 mole of NaOH equal to 1 mole of HCl. So mole of HCl unreact is 1.237 times 10 to the power of negative 3 mole. After that, we need to find HCl reacted, which is mole of HCl initial minus mole HCl unreact. So we get 23.763 times 10 to the power of negative 3 mole. After that, we need to determine mole of CaCO3 to obtain its mass in the sample. So now we use equation 1. We can make ratio of HCl to CaCO3. So the ratio is 2 HCl equal to 1 mole of CaCO3. Our mole HCl is 23.763 times 10 to the power of negative 3. We need to divide by 2. So mole of CaCO3 equal to 11.882 times 10 to the power of negative 3 mole. After that, we need to find mass of CaCO3. Mass equal to mole times molar mass. Firstly, we need to find molar mass. Molar mass we get 100 gram per mole. So mass of CaCO3 is 1.1882 gram. Lastly, we find percentage of CaCO3 in sample. For percentage, we use weight over weight. And then we get 57.68%. That's all. Thank you.
And for the discussion, first, what is the phenolphthalein color change? It changed from colorless to pink. Then, why is phenolphthalein is used as the indicator? It is because it has a strong acid which has HCl and weak base calcium carbonate relationship, which the pH range lies between 8.3 and 10. Then, why do back titration is applied in this experiment? This is because the molar concentration of an excess reactant is known but needed to determine the strength of the concentration of an analyte, which also commonly used for insoluble salt.
in this experiment is calcium carbonate. Then why the solution need to standardize? It is because titrants can age over time and thus their concentration will change. So in order to get an accurate result, it is important to standardize the solution.
Now we move to precaution step. We have 5 precaution steps. First is handling reagent. Use glove and safety goggles when handling hydrochloric acid and sodium hydroxide. Both are corrosive and can cause harm if contact with skin or eyes. Second is measurement accuracy. Use a clean and calibrate burette, pipette and balance for precise measurement. Read the meniscus at eye level to avoid parallax error when measure liquid volume. Third is avoid loss of material. Ensure no spillage of eggshell, powder or solution during transfer or reaction. Use a funnel if necessary to pour solution accurately. Fourth is indicator use. Add only 2 or 3 drops of phenolphthalein indicator to avoid color misjudgment during titration. Last but not least is avoid contamination. Rinse all glassware with distilled water before use to remove impurities. Use separate dropper of pipette for HCl, NaO, and indicator to prevent cross-contamination. Now we move to conclusion. In conclusion, the objective have achieved when the percentage of CaCO3 in eggshells is 57.68%. This value highlights the primary composition of eggshell and demonstrate the effectiveness of back titration in determining the CaCO3 content in biological samples. Calcium carbonate is present in eggshells and the primary structure component. This is because calcium carbonate forms the bulk of the eggshell structure, providing the mechanical strength and rigidity needed to protect the contents of the egg. This strong outer layer ensures the egg remains intact against physical stress during handling, nesting or incubation. That's all from us. Thank you.